We're seeing that emerge over the last 20 or 30 years to the point now where the inequality in America has 0.1% of the population owning more of the wealth than 90% of the population. To put that in perspective, the last time that happened was 1929. And I think technology has really been at the heart of creating this divide. And so it's something that we really need to figure out. Because as nice as it is to be able to order a pizza with a single touch of a button, if I don't have money to do that, it's kind of irrelevant. Where I think we need to go with this is start to understand this interface between humans and machines. We need to get more of us that can interface with the machine and actually add something to it. The reality is that the hack system that Zach S. was playing with was a hacked system. It wasn't designed with any kind of interface. Even today, the interfaces that we create to allow people to interface with meteorological models are rudimentary at best. We've done very, very little on designing this interface between humans and machines. We've done a lot on designing the AI, but very little on designing the interface. And I think we need to really start to make a push towards getting much better as a global society at designing interfaces to allow us to engage with machines, because not all of us are mildly autistic idiot savants who can engage with eigenvectors like a second language. There's enough of them in Silicon Valley, and there's probably enough of them in the world. Yeah. They're actually lovely. They run most of the companies. To do this, though, we need to understand the human brain. If we want to understand the interface with computers, we need to understand the human brain. And particularly, we need to understand what it is to be an expert. Experts have this kind of this sense of intuition. You all sort of know it when an expert is there, and then they have this sense that they just kind of know. It's like, yeah, I kind of know what's going on here. It's like the car mechanic who looks at the engine and steps back and says, yeah, I heard what was going on. It's probably the carburetor that's busted. They have this sense of intuition, and for the longest time, we almost thought this was kind of magical, an intuition of experts that just sort of knew what was happening. But actually, some of the most interesting science over the last couple of years has started to pick apart what it is to be an expert and what it is to have intuition. And there was a paper by Wan and their team out of China that was published in Science that looked at this very question, what it is to be an expert and to have intuition. And so they were able to do this by quite an ingenious experiment, really. They went back again to this model of chess, which has proved to be kind of a very interesting testing ground. And what they did was they took two sets of players, experts and amateurs, people that were exceptionally good at chess and people that just were kind of okay at chess. And they stuck them into an fMRI machine and projected images of the chessboards up above their retinas. And they did this, and as they did this, they measured the flow of blood through the brain, as an fMRI machine does. But they did this only for a second. They only showed the image for a second. And they did that because they wanted to remove the conscious thought process. They wanted to go down to the subconscious level for these chess players, to see how the brain was operating when you weren't thinking about things. And what they found was fascinating. The first thing they found was an area of the brain lit up much more strongly for experts than it did for amateurs. And that part of the brain was called the precuneus. It's sort of up into the back of the brain. For those that know neuroscience, it's the part of the brain that's associated with finding signal within noise. It's the part of the brain that's associated with abstracting a pattern where everyone else sees only noise that's around. And so what this really showed was that when a chessboard was shown for less than a second, the experts subconsciously were able to see patterns, whereas the amateurs saw only noise that was surrounding them. The next thing they did was they flashed up this image, and they did that for 2 seconds, about that long. And they said, choose your next move. And what they found when they did this was actually a different part of the brain lit up. And a different part of the brain, this time, was the caudate nucleus. The caudate nucleus is down to the back of the brain, just above the basal ganglia. And it's kind of the reptilian part of the brain, very, very old, and it's associated with learned response functions. And what they found was that it not only lit up for the experts, and not at all for the amateurs, but that it lit up in a really interesting fashion. It lit up in a way that was highly correlated with the success of the move. The stronger the signal from the caudate nucleus, the more likely it was that the move that was guessed by the